here. And I didn't do a Jamboard for this, but we're going to look at the ebook. So if I go to ebook, and we did kind of 1 through 5 yesterday. And so I'm going to continue some of the problems. We didn't do D and F, so I'm going to do D and F with you. And then we did 6 yesterday, and then we're going to do 7 today, which we haven't done. Okay, so let's look at number 5. We'll start with number 5, D and F. So we're going to write that on our paper. We annotate here, number 5. So 3-5. What are we doing? F. So F says, hopefully I have enough room to, I'm sorry, I'm going to do D. So let me change that back to D. Okay, we'll start with D. D is 5 over X. So we're just continuing the last class lesson, but with more examples, equals 4X over 3. And we're going to learn cube root today, which we didn't do last class period. Okay, we're getting some good math this semester, guys. We're going to get deeper and deeper into stuff that we didn't do in Math 1 or Math 2, right? This is going to be like Math 3 stuff. So we're starting to get into math, like real Math 3 territory. Okay, so we have 3 fractions here. In order to add fractions, you have to have the common denominator. So we can make common denominators, or I can multiply by the lowest common multiple of these 3, right? What is the lowest common multiple of x, 3x, and 3? Should be 3x, right? So I want to multiply the whole thing by 3x. I'm going to multiply this side by 3x, this by 3x, this by 3x. I'm going to multiply the whole thing. You know, let me just put like 3x right here, and then 3x right here. We're multiplying all 3 of the terms by 3x. When we do that, that's going to eliminate our denominator. So this has an x and that has an x. So that x is going to go away. That x is going to go away. I just have 3 times 5 is 15. So just fraction busted and got 15. When I multiply these two, this 3x is going to cancel with that 3x, and I'm just going to get 1 plus 1 equals. And then here, the 3x's are going to, the 3 is going to cancel with this 3, but I'm still going to have an x. So 4x times 4 is 4x squared. So we do have an x squared in this problem, just to make sure, yes, this x went away, that x went away. So over here, there's no x's. We just have 16 is equal to 4x squared. Oh, that makes things easier. We don't have to factor or anything for this problem because there's only an x squared term. So I'm going to undo the 4. Going to undo the 4 here, and 16 divided by 4 is 4, so 4 equals x squared. Well, there's 2 numbers that I can square to get 4, so I'm going to take the square root of that, the square root of this, and put a plus and minus, and so x is equal to positive and negative 2. Okay, now one thing is on these problems is it says be sure to check your solutions algebraically. And on your worksheet today, it's going to say check your work and make sure there are no extraneous solutions. Okay, and I'm going to write that out in a second.
Ms. Wakefield, you're muted.
Thank you. I forgot to unmute myself. So we want to check there are no extraneous solutions. Thanks for letting me know that. Extraneous solutions are solutions that you get. So I got 2 solutions here, but 1 or 2 of them might not work. Sometimes we get solutions that, especially when you square things, you create an extra solution that's not actually a solution. So you have to actually check that they work. So we have to plug them back in. So I'm just going to do that for D right here. Let's plug in 2 and negative 2 to see if it works. So if I put 5 over 2, this is my check, right? I'm going to put 5 over 2 plus 1 over 3 times 2, which can I just make that 6 because 3 times 2 is 6. Equals 4 times 2, which is 8, thirds, right? 4 times 2 right here is 8 thirds. So we want to make sure that works. I need a common denominator here. So I need to make this, multiply this by 3 over 3 to make it 15/6 plus 1/6 is 16/6. Does that equal, sorry, but 16/6, does that equal 8 thirds? If I reduce this, right, by 2, I did reduce this by 2, that's 8. I reduce that by 2, that's 3. So yeah, these are equivalent. 16/6 does equal 8 thirds. So this checks out. So positive 2, x equals 2 works, right? X equals 2 is a solution. Now I need to check negative 2. So I need to plug in negative 2. So I'm going to check negative 2 over here. I'm going to do 5 over negative 2. I'm going to make this minus because it's going to be 3 times negative 2. So it'll be minus 1/6 equals, and then 4 times negative 2 is negative 8 thirds. Okay, very similar to the last one, just some negatives in here. So I want to again multiply this, change my color here, by 3. Well, there's a negative out in front here. I can stick this negative up here. I'm going to stick this negative up here and make this positive. So I get a common denominator down there. Multiply by 3 over 3. And I'm going to get negative 15/6 minus 1/6 equals negative 8 thirds. Okay. All right, now that I have a common denominator, I can combine these two numerators. That's negative 16/6. Does that equal negative 8 thirds? Well, I believe so, because we had positive 16/6 equals positive 8 thirds. So when I reduce this, yes, I'm going to get negative 8 thirds equals negative 8 thirds. So this checked out. X equals negative 2 is also a solution. And hopefully I'm not sure if there's one in this section, but in one of the next sections, we'll do problems where one of these won't work. And so like, let's say this didn't work, then I would say, that's not a solution. Only 2 is a solution. Okay. But right now it did work, but that's what I mean when you're checking it. Okay. So we need to do F. I need to erase this work. So if you need to take a shot of it really quickly before I erase it, I'm going to go on to F. You can start copying now, problem F. All right, F says 6W minus 1. 6W minus 1 over 5 minus 3W equals 12W minus 16 all over 15. Okay. Very similar problem to what we just did in D. We have fractions and we need a common denominator, or we need to actually get rid of the denominators, right? I need to get rid of the 5 and the 15, those denominators. I need a fraction bust. So what would I multiply by? What is the lowest common multiple of 5 and 15? That would be 15, right? So I'm going to multiply all of this by 15. So I'm going to multiply the first part by 15, the second part by 15, and the last part by 15. Okay, when I multiply the 15 and divide it by 5 here, so 5 goes into 15 3 times. So I'm going to have to do this 3 times 6W minus 1. Right, I'm going to have to multiply 3 times 6W minus 1. This nothing cancels, so I'm just going to go ahead and multiply this, which is negative 45W. Here the 15s cancel out. That's nice. So we just have the numerator here, 12W minus 16. So we fraction busted. We got rid of all the denominators by multiplying by the lowest common multiple. Now I'm going to distribute here. 3 times 6W is 18W. 3 times negative 1 is negative 3. Minus 45W equals 12W minus 16. Now we just got to combine like terms and stuff. So let's see. When I add the 18 and the negative 45W, I'm going to actually subtract those. That's negative 27, negative 27W. And then the minus 3 equals this stuff, 12W minus 16. 2 steps here to solve this problem. Let me add the 27 since this is negative. I'm going to add 27W over here. Okay. And let me go ahead and move the 16 over here. So I'm going to add 16 over here, add 16 over here to get rid of that from that side and get rid of this from this side. 16 minus 3 will be 13 equals, this will give me 39W. That's nice because now I'm just going to divide by 39, and W is going to equal 1/3. Okay, and I should check this answer. I should plug it back into this equation to see if it works. I'm going to assume it works, but you know, especially if the directions say to check for extraneous solutions. All right, so that's just a couple of review problems here of how to solve and fraction bust. We did that before the break, so I just wanted to review that since we didn't have time last time to do it and we have more time today. So I'm going to clear this away and go to number 7. Clear this, go down to number 7. We're going to skip 6 because we did it yesterday. 7 here. All right, this is some good stuff. Consider each of the following equations. What structure can you see that might help you rewrite the equations as Graciela did in 3.6? So in 3.6, we used U-substitution, right? Indicate what your box or repeated piece is. Be ready to share your ideas with class. You do not need to actually solve the problems. We are actually going to solve the problems because you have to solve them mostly on the homework. So this is called U-substitution. Why are we using it? Because take a look at this problem right here. This looks pretty complex, right? Like m squared plus 5m minus 24 squared minus the same thing equals 6. I could multiply this all out and have like a big, huge rectangle, but I don't really want to do that. And I don't think you want to do that. I don't think we want to do like, we have a lot of stuff here, like m squared plus 5m minus 24 times m squared plus 5m minus 24. We'd have like a 9 rectangle, and I don't think we want to do that. So let's erase that. So there's a shorter way to do it, and it's U-substitution, right? So let's, what are we going to let U equal? We have to find what to let U equal. So let U equal, and you have to copy this down. So let's go ahead and copy that down. If you haven't, go ahead and copy m squared plus 5m minus 24 squared minus m squared plus 5m minus 24 equals 6. I'm going to give you a second to copy that down. I'm going to let U equal the m squared part because they're the same. You can see how they're the same. So that's what you want to let U equal. I'm going to let U equal m squared plus 5m minus 24. Okay, that's what U is going to equal. U is going to equal that. So I'm going to replace these two with just U. So we have U squared minus U equals 6. Okay, that looks a lot less complex than doing that, right? And it is way more less complex. So I have to get this equal to 0 to solve a quadratic equation. So we need to subtract 6 from both sides first. So U squared minus U minus 6 equals 0. Now this is very factorable and very easy to factor. So I'm going to go U times U equals 0, right? And the factors of 6 that differ by 1 would be 2 times 3. And I need a negative 1 in the middle, so the 3 will be negative and the 2 will be positive when I add those together. And that's how you factor. And let's go ahead and solve this, right? I'm going to set this equal to 0. Can I just say u equals -2 and u equals 3? Can I skip one step? Hopefully by now you can skip that step. Okay, we solved for u, but we need to solve for m because that's originally what was in the problem. So we need to back substitute again. We need to substitute in place of u. I'm going to substitute what I replaced u with, which is m squared plus 5m minus 24 equals -2. Okay, so I replaced the u with that big long thing. And then I got to do that for this one too. So I'm going to do m squared plus 5m minus 24 equals 3. Right, we got 3. So that one's equal to 3. This one's equal to -2. Now we got to solve these. These are quadratics. So we're going to add 2 to both sides. And I'm going to get m squared plus 5m minus 22 equals 0. And let me go ahead and subtract 3 from both sides here to get it equal 0. So we can solve a quadratic. M squared plus 5m minus 27 equals 0. Okay, when I try to factor this, I go m times m for my m squared. And then for my 22, I automatically think of 2 times 11, right? But when I do 2 and 11 and I get -22 up here and 5, there's no way for these to make 5. So it means that we can't factor it like this. And those are really the only factors. I can use 1 and 22, but that's not going to make 5 either. Yeah. So this problem doesn't factor, right? It doesn't factor. And when I do the same thing for over here, when I try to factor this one, right? When I think, so I'm going to factor the m squared, m times m. When I factor 27, I automatically think 3 times 7. You know, I can make 10 or 4, but this isn't 4, right? 7 minus 3 is 4, but that's not a 4. So this isn't going to work either. So this doesn't factor either. So this whole thing doesn't factor. Well, if something doesn't factor, how do we solve it then? If a quadratic does not factor, what do we have to use?
A different method?
Yes. What is that method?
It's the what is it called? The quadratic formula?
Yes, exactly. The quadratic formula. You have to use the quadratic formula when something doesn't factor. And the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This is something we don't want to forget. It's not like, oh, we learned it, and we did it, it's over. No, it recurs, it comes back a lot. It's something you need to know for pre-calc and calculus. Okay, so we need to plug in 1, 5, and -22 into the quadratic formula. 1, 5, and -22. So x equals -b, so it'd be -5 plus or minus, then I square that 5, 25, minus 4 times a times c. Well, a is 1, c is -22, all over 2a, which is just 2, because a is 1. Okay, let's reduce this. What is 4 times 22 is 88. So I have -5 plus or minus, let's see, 25 plus 88. Right, you got to do this part first, the 4ac part. That's positive because a negative times negative is positive. All over 2 is 25 plus 88. I didn't work this out ahead of time. Is 113. So we have -5 plus or minus square root of 113, which is like 10 point something, over 2. Okay, so that is your exact value answer. If you put it in your calculator, you're probably going to get decimals, and the 2 decimals that you're going to get are, I'll write it down, I did calculate that, 2.8, my calculator, 2.815, and it goes on, and you're also going to get -7.815. Notice how the last 3 digits are the same there. Oops, that's a 5. Okay, so these two answers, but the exact value answer, of course, is always better. Okay, and I could do the same thing for part 2. I'm going to speed it up a little bit. I could do 1, 5, and negative 1, 5, and negative 27. Okay, I would put it in the quadratic formula. Well, those two answers in decimal form are going to be 3.266 and negative 8.266. And I'm going to plug one of my videos here. If you go to my my Math Magical Life channel that I post all my math videos on, I actually show you how to program the quadratic formula into your graphing calculator so that all you have to enter is like the 1, the 5, and the negative 24, and it will calculate these two answers for you. So you can check that out on my channel. All right, so that is number 7A. Let's look at B, C. And so it says we don't have to solve all these. I wanted to solve those just to get us an idea of how to do that. Okay, I'm going to go on to B here. B. All right, let's copy down B. B says x to the 2/3 minus x to the 1/3 minus 56 equals 0. Okay, take a look at that. First of all, we have fractional exponents. It's going to scare some of you, right? What do we do? What are fractional exponents? We did that last semester. I don't remember what that is. Well, if we took away the third and this third, we wouldn't have fractions anymore, right? So how is a way that we could take away that? And that's going to be by using U-substitution again. So we want to let U equal something. Right? If I take away a third, I'll have an x squared, and I'll just have an x here, and it'll look like normal. So what I want to make x be is just let U equal x to the 1/3, x to the 1/3 power. Okay, because we have a third here and a third here, and usually if you look at the middle term, that will tell you what you want to let U equal. You basically want to let U equal that guy right there. Okay. So what that does for us is this. Undo all that. So it does this. We can let this be U squared minus U minus 56 equals 0. Okay. So the x to the 1/3, when we take that out, that just leaves us with U squared minus U minus 56. And this looks a lot nicer, right? When we use U substitution. So this is going to get us, oh, we can factor because 56 is very factorable, right? So U squared is U times U. 56 is 7 times 8. And then since it's a -1, this is going to be -8, +7. And then we can solve this. Hey, U equals -7, U equals 8. Now I'm going to back substitute the U back in. I'm going to substitute this back into here and here. So we're going to get x to the 1/3 equals -7, and x to the 1/3 equals 8. Okay, and if you recall for first semester, what does 1/3 mean? You know, 1/3 power. 1/3 power is the cube root. Okay, so it means we're going to take the cube root of something to get -7, and you can take cube roots of negatives, but we want to get rid of this third. So actually, to get rid of this third, we're going to multiply by a 1/3 power. So I'm going to cube this over here too. Okay, I'm going to cube that. And then here, I'm also going to multiply this by a 1/3 power to make it 1, and then multiply this by a 1/3 power. Okay, so x equals -7 to the 3rd is, get our calculators, -343. Right? So -7 times -7 times -7 is -343. Okay. And then when I do this, I'm going to get x equals 8 to the 3rd. 8 times 8 times 8 is 512. Okay, so right now we're just using the exponent button, but in a second I'm going to show you how to use a cube root button for the next problem. Okay, so that one is, all right, that one's done. We need to look at C. So I got to erase all this. Okay, and I don't think we'll solve all of C. We'll just do C because you need to read directions, and it says you do not need to actually solve the equation. It says that on half of your worksheet, today on the second half of your worksheet. Y to the 6 plus 3y cubed minus 18 equals 0. Okay, what do we want to use? How do we want to use U substitution? What do we want to let U equal? Because right now you could factor this, but most of us don't know how to factor. How do I factor y to the 6? Well, if I can get this down to like a y to the 2nd, then I can factor it, right? That's what I want to try to do. I make it lower. And remember I said, take a look at the middle term. That's what you want to let U equal, that middle term. Let U equal y to the 3rd. Okay, so we're going to let U equal y to the 3rd. Why? Because what is y to the 3rd squared, you guys?
Y to the 6th.
Very good. Y to the 6th, right? And so if I let this equal y to the 3rd, if I let U equal to y to the 3rd, then I'm going to get U squared plus 3U. Okay, so this is just going to become a U, and this is going to be U squared. U squared plus 3U, I'm sorry, I wrote a y there, minus 18 equals 0. Let me erase that. That should be a U. U squared plus 3U minus 18 equals 0. Okay, so now we could factor it, and we could hopefully factor this problem. Yeah, this problem does factor. U squared is U times U. 18 is 3 times 6. And then we have positive 3, so it's positive 6, negative 3. Get U equals 3, U equals negative 6, and then we back substitute. We put y to the 3rd. Yeah, let's actually do this one. I'm running out of room here. Y to the 3rd equals 3, and y to the 3rd equals negative 6. Okay, so when I substitute it back in, after you solve for U, you got to substitute it back into the problem. And I want to solve this. This is where the cube root thing comes in. And I think this is a good thing. This is something we should learn for how to use on your calculator. So I need to take the cube root, right? This is how do you get rid of a 3rd power, is you take the cube root. I need to take the cube root of 3. I need to take the cube root of this and the cube root of negative 6. And you can take a cube root of a negative. Okay, this is how you do it on your calculators, guys. I put it on my Jamboard here. I kind of have to move this around. I don't want to erase all this. Please write this down. This is kind of pretty useful right here. Perfect cubes. You probably don't know your perfect cubes, so please write this down. Okay, I'm going to give you a second to write it down. 1 to the 3rd is 1. 2 to the 3rd is 8. 3 to the 3rd is 27. So 27 is a perfect cube. You should know that. 4 to the 3rd is 64. 64 is a perfect cube. 5 to the 3rd is 125. That's a perfect cube. So if I took the cube root of 125, I would get 5. Okay. So I'm going to give you time to write this down quickly. 6 to the 3rd is 216. So if I took the cube root of 216, that would be 6. Okay. 7 to the 3rd is 343. You're going to see that in your homework a little bit. Okay. Cube root of 343 is 7, because 7 times 7 times 7 is 343. 8 to the 3rd is 512. I think we just did a problem with 512, right? Yeah, the last problem had 8 to the 3rd in it, had 512. And the last problem had 343 in it also. 9 to the 3rd is 729. And of course, 10 to the 3rd is 1,000, 3 zeros. Okay, so those are the ones you need to know. So there you are. I hope you wrote it down. And how do we do cube root on a calculator? Okay, I want to erase some of this. Let me erase some of this so we can see some stuff. Okay, how do we do this on a calculator?
Doesn't it depend on which calculator you're using?
Yeah. So guess what, guys? Look what I did. I've put a calculator on here, but there's only really 2 calculators, and all calculators pretty much work the same. You just have to find your button. Okay, so.
Don't you press like the kind of up arrow button and then the number that you're.
Yeah, you put the number first and then the up arrow button, but you have to press second. Okay, so let me get my eraser. I need to erase some of this because it's in the way. Erase this guy. Okay, so these are the 2 calculators that we recommend for you to have, TI-30 or the graphing calculator. So I'm going to show you how to do it on both. Okay, so you need to type the 3 to tell your calculator. Remember, calculators are dumb. You have to tell them what you want them to do. So you have to type 3 first to tell it you want the 3rd root, because you could take the 4th root, you could take the 5th root, you could take any root you want with the calculator. So you're telling it, you type in 3, it's going to say 3 here, and then you press the 2nd or shift button, whatever calculator you have. This is the 2nd button right here. And then you're going to press the up arrow button, because right above it, you'll see the little X root button. You'll see a root button right above this exponent button. So you press that. So that should give you on your display now, it should say something like that. And let's just put, I don't know, what did we want to take the root of? 7 or 2? Or, oh, we want to take the root of 3, right? We want to take the 3rd root of 3 right here. So, and that's 1 point something. Wrote it down somewhere. Knock down that calculator. I need it. So I think it's 1.19 or something like that. So cube root of 3 is 1.44. Okay, so you should get equals approximately 1.44. Okay, so that's one of our answers. We also wanted to take the cube root of -6. So do the same process, 3, second, that. Try it. You got to try this in your calculator, because somebody's going to ask you on a test, Miss Wakefield, how do you do this? And now's the time to practice, not during a test. -6 is -1.81. -1.81. So if I cube -1.81, I'm going to get -6. Okay, so that is how you use the cube root button on that calculator. On this calculator, there's the cube root is on the math button. So if you have a, does anybody have? Can you put in a comment if you have a? You can do a private comment to me in the chat if you have a graphing calculator. That way I know if I'm wasting my time or not. Once you press the math button, you'll see 1, 2, 3, 4, and on the 4th one, it'll have a cube root. So press 4, and then type in what you want to take the cube root of. So cube root of 3, and then good. One person has the calculator. Somebody put in the chat. Yay, good. So I hope you're using this on your calculator. Can you put, let me know if you're using it, if it's helpful for you. Cube root of 3, and you get 1.44, right? So it's on the math button right there. It's nice because you have a dedicated cube root button. There's a lot of functions in the math button. There's a lot of functions in all these buttons up here. So don't worry, you can't break your calculator. So just try and use it. Mostly you can't break it. All right, so that's how you do cube root. I wanted to show that to you today in class. So if you have any questions, I'm happy to help you in my office hours. My office hours are Tuesday, okay, 2 to 3, every Tuesday, 2 to 3. I didn't have them this week because it's first week back, but let me know if I don't show up for some reason. Just go into the my Zoom, and I'll get a notification that you're there. And if I see it in time, I'll pop in and help you. All right, so that is how you do cube root. All right, so we did that problem. What problem are we on now? So we did C. D, I'm going to skip. E, I'm going to skip. Okay, A, B, C, that's good. All right, so we A, B, and C. So you get the idea of U-substitution. That is the main thing that I wanted you to understand, because on your homework, you're going to have some U-substitution stuff here, right? You're going to have, so you have to solve these using fraction busters, like the first 2 examples that I did. Here you can get rid of a bunch of the zeros. Oh, I did want to do 11 and 13 because those are a little different. So let's do 11, 13 really quickly. For 11, how do you solve it if you have 6 to the 2r equals 216? Okay, how do you get rid of that 2r? Well, you don't. You need to change the 216 to a power of 6. These need to be the same base. And if you remember the slide that I showed you, the slide that I told you to copy down the perfect squares, 216 is 6 to the third power. So that's one of the reasons why I had you write it down. Okay, 216 is 6 to the third power. So I'm going to change this to 6 to the third power so that it will have the same base as this one, because we want the bases to be the same. Because once they're the same, then you can just set this equal to this, since they're equal, right? If this is equal, then the powers have to be equal. So 2r equals 3. So we could just drop the bases and just set the exponents equal to each other, and then just solve, divide by 2. So r equals 3/2. And you'll see that at on the bottom. And plug in 2 times 6 to the 2 times 3/2 would be 6 to the third, which would be 216. Okay, so I'll do it for number 13 too. I'll do one of your homework problems here. 13. 81 to the k power is equal to 1 over 27 times negative 3k plus to the negative 3k plus 3 power. Okay, we need to change these to the same bases, 81 and 27. Well, if you look at that perfect cubes thing that we did, I'm going to click back to it if I can. Let's see, where's the cube? 81 and 27 here, and go back to here. You see 27 is the cube of 3, and 81 is actually not a perfect cube. It's a but it does have to do with a 3. So let me go back to where is my, oh, I'm going back to the worksheet. Let's see, there we go. So this is 3 to the, I got my pen back. This is 81 is actually 3 to the, I think 9 times 9, right? 81 is 9 times 9. Well, 9 is 3 squared. So 81 is also 3 to the 4th, because 9 squared is the same thing as 3 to the 4th. But then I'm going to put times k right here, right? Because there's a k right there. So 81 is 3 to the 4th times k. 27 is 3 to the 3rd, right? So how do I get 1 over 27? That's 3 to the negative 3rd. Remember, 3 to the negative 3rd power is 1 over 27. Okay. So 3 to the negative 3rd times this stuff, negative 3k plus 3. So now that our bases are the same, that means that our exponents have to be the same. So I could just drop the bases and go 4k equals, and let's go ahead and multiply this out. Negative 3 times negative 3k is 9k minus 9. Now I could just solve it. Subtract 4k over here, subtract 4k. Let me bring the 9 to the other side over here. And I get 9 equals 5k. Divide by 5, divide by 5, k equals 9/5. Voila. Okay, so that is how you solve this. All right, guys, so let's see, somebody put something in the chat. All right, so that is the notes for today that you need to submit. Let me clear this out. So you need to submit these notes into the Google Classroom. That is the wrong thing. That was the wrong thing. Where's my Google Classroom? Here we go. So you need to submit
Mr. Wakefield?
stuff into Classwork Theory. Hold on one second. Let me pause this. Okay, guys. So yeah, you want to turn in your notes today, and 4 people have turned it in. Awesome. And then you have time to work on your worksheet. I think we're ending a little early, like almost an hour early or 45 minutes early. So you have time to start the worksheet and get that done. And then I will see you guys again on Tuesday.